So we're going to be going through this code and making sure that we understand all what's happening. So we said that this is called upcasting because we're taking a subclass and we save it, we store it inside of a superclass type. Now if we call this this s1, if we print it, we're going to be calling the method toString, and the toString, the one that is going to be called, is the one coming from the circle. Why? Because that's the class, that's the value, that's what's inside the shape. Inside the shape there's a circle, and also in that circle there's a toString that is overridden. So there's toString that is defined inside this circle. That's why it is going to first try to find if there's a toString. If there's no toString inside this circle, it will move up to the subclass of toString of the circle and see if there's a toString. And in this case there is. So this is going to be a shape. So if I remove, for example, this one, I run, what I'm going to see is that's going to show me the shape. Why? Because in the shape there is a toString. Logically, this is the first thing that you might have been your choice. You could have said, okay, you know what? This is the shape that I'm going to see. Why? Because S1 is shape. However, when you do this kind of downcasting, then you store the subclass into a superclass's data type, the first thing that is going to be executed is the things that are coming from the subclass, if they're available. If they're not, it just tries to go up. For example, let's say if in the shape there is no toString, now it's going to go for the toString that is coming from the object. Yeah, because every class inherits from object. Yes, you had a question.
Maybe you will add something, the toString that is in class circle.
Yes.
So you can't leave class circle and give it like what's in the shape.
I don't get your question.
Maybe you add give anything in that toString.
Maybe there's no toString, or maybe there's a toString and what's inside is different?
Yeah, different than the shape.
But it is, like in this case, this toString is different from what's in the shape. Look, this is what's in the shape, this is what's in the circle. They are different because in the circle it says circle, in the shape it says shape. So they're different.
So when you take the one in the circle,
So if I have one in the circle, this is the one that is going to be executed. Now if I don't have one in the circle, and I run, okay, so we were here talking about the toString. Now if I delete the one that is coming from the circle, I said when I run, now it's going to be showing the one that is from the shape, because there is one from the shape. What if now I don't have one from the shape, and I don't have one from the circle? Then it's going to keep going up, because I know that there's a toString somewhere, so I'm going to use it. But the first one is going to be using the one that is from what's inside actually the shape. Now the second thing is, let's go down about this, or maybe let me see it from here, it might be easy. Oh, no. So like for this one now I'm calling get area. Now which get area is it? From the circle? Exactly, the same thing. The same thing applies again. It's going to be from the circle. Get perimeter from the circle. Get color. There's no get color in circle, but I have a get color coming from shape. So this is going to be giving me the one from shape. Yes?
If I call like get area from the circle class and shape does not have get area, it cannot be appeared
If then repeat your question. If you'd like to call what?
the get area and it does not appear, it does not exist on.
But the get area exists in the in the shape.
Yeah, I mean if it's not.
If it does not, you cannot use that. Yeah. And that's now it's filled, same thing. We're going to see it. But this one is a problem. Why is it a problem? It should not be a problem, because I have a get area, I have get perimeter, get color, get is filled. all these are available in the circle. And also from the circle I have get radius. Do I have get radius? Yes, I do have get radius somewhere. Now I'm in the shape. Let's go to the circle. And in the circle I have get radius. Now if I just copy everything and paste them in NetBeans, you're going to see everything is going to be okay except this. And why this is a problem is something that I need to pay attention to, because it's a small detail that might be overlooked, but it's a real problem. Now this will not be the same if instead of doing shape I do circle. If I do circle, everything is going to be clear, no problems. I'm using everything from the circle. Now if I do shape, now get area exists in shape and in circle. Get perimeter exists in shape and in circle. Same thing for get color, it exists from shape, so it's available in the circle. Same thing with its field. But this get radius is only in the circle and not in the shape. But S1, what is the base data type? That's a shape. So you cannot call something that does not exist in the shape. When you call a method, it's only methods from the shape or those ones that are in common. But actually they have to be in shape. The main thing, I'm calling all the methods that are available in shape. So you see, this is toString that is available in shape, but if also there's one in the circle, I'm going to use the one in circle. This is available in shape. Actually this is abstract, but it's there. So I'm going to use the one from the circle. Circle, 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 except this one. It's not available in the shape. No. So this is a problem. You see, this look at the message. Cannot find symbol. It cannot find get radius inside of shape. Yes.
I have I'm calling get color. It's on the shape, but it's not in the set. Is it going to be an error?
Like this is not an error, as you can see.
It's not in the.
It's not an error, but because if it's in shape, I can inherit it from in the circle. So it's like it's in the circle. But the opposite is not the case. Like here, get radius. So very important to pay attention to this detail. When you look at the methods that I can call, and this is some question that I can find maybe in the quiz or in the midterm, who knows. So pay attention to those details. Now let's do something like this. This is downcasting, which means I'm taken from the superclass to subclass. Yes, a question?
Can I answer? That you should put abstract in the shape for get radius.
No. No, you don't have to. It's just what you mentioned, there's a problem. What's the problem? You need just to tell the problem. How to fix the problem, that's another thing. Now that's a good point that you brought that, because in the quiz or the assignment or any question, if I tell you what's the problem, don't talk to me about the solution of that problem. Because what's more complicated, to tell me the problem and its solution, or just the problem? So if I ask you about just the problem, tell me just the problem. Because you might give me a solution that is wrong, and you might mess up everything. So if I ask about the problem, tell me only what's the problem. If I tell you how to solve this, then yes, try to say, okay, one way is to put radius as abstract, have an abstract get radius in the shape. That's one way, but that's not maybe the best way, but that's one way. It will solve the problem. So now what if I ask you, is this, what kind of question I might ask you is this a valid statement or not? No, so your question would be, no, it's not valid. What kind of error should I get? Is it a runtime error or a compilation error? So this one is which one? If you see a red line, that's compilation. If you don't see a red line, then you run and then you have a problem, that's runtime. So the runtime is when I run, then I see the problem. The compilation is before even I run, there's a problem. When I compile, try to understand if the code is okay, there's a problem, then this is a compilation error. So that's the kind of mistakes that you need to pay attention to. So this is why this one is not okay. Now let's continue with the rest. Now if I have this thing, circle S1, this is okay because inside S1 this is a circle, even though it's a shape, but I can convert it back to a circle. Now if I do C1, this is the call to toString. Which one is going to be called? Of course this is now a circle, and there's a toString in circle, so it's going to be the one from circle. Get area, get perimeter, get color, is field. How about get radius? Is it going to be a problem? This time it's not going to be a problem, so I just copy this and put it down there. That's not going to be a problem, as you can see, because in C1 is a circle, and then a circle has get radius, so it's okay. Now what about this thing? If I create shape S2, new shape. That's not possible. That's not a legal statement. That's an error. Is it a compilation error or runtime error? Compilation, because I cannot even before I run, it will tell me that this is an error because the class shape is abstract. I cannot instantiate an abstract class. So if I do something like this, this is the kind of error message. If you read that error message, this is what it means. Shape is abstract, cannot be instantiated, means you cannot have an object from the class that is abstract. So this is not okay. And this is, as you said, a compilation error. Now let's keep going. This thing here. Is it okay? I'm doing upcasting. Upcasting is the easiest part. You just make sure that it's a subclass of where you put. That's it. So if I do this rectangle that I put inside of a shape, so that's fine. Now this S3 is going to call the toString from rectangle. What about the get area? Rectangle, get rectangle, rectangle, rectangle. Oh, get color is not from the rectangle technically because I'm inheriting it, so I can use it. But the get length is also from the rectangle, so that's fine, right? No. This is the same thing for the get radius. This get length is only available in rectangle but not in shape, which means now this is not okay. You had a question? Now if I do this, everything is fine up to get length. That's not okay because get length is not present in shape. So that's the same problem. This is going to give me a runtime error, right? Compilation. Just I would like to make sure that you don't mix up things. Yes. Now if I do this thing, S3, what is S3? This is a shape. What's inside of it? It's a rectangle. So it means I can do this downcasting. And if I do rectangle, display this thing and the get length, now this is okay. No, this is not going to be a problem. Okay, let's keep going. What about this? Another upcasting. Is it? This is square. The superclass of square is not shape, but rectangle. When we do upcasting, do we have to be the immediate? No. It can be one of the parents of that class. So it can be the immediate one or one of its ancestors. So this is okay. So when we do this kind of upcasting, it does not have to be only the immediate one. It can be anyone that is from up there. I can even do this into the object, because object is the base class of all. And also I can do the rectangle as you just mentioned. Just need to spell it right. Rectangle. That's okay. So in this case it's shape S4. And then this is going to be calling the toString from the square. Is there a toString from square? I just remember that maybe we did not do it. Did we? Yes, we do it. We did. So we have this toString from square. And then toString from square get area from the square rectangle from shape from the square. But you forgot, there is no get area from the square. Because you see, in this square, I only have the constructors, the get side, get length, set width, toString. And the get area and get perimeter are coming from the superclass. Let me just remind you by showing this. Oh. You see, I have get area here, but not here. But because I'm inheriting from rectangle, it's like they're available. But if I tell you what this get area, where is it coming from? You should not say square. It's coming from rectangle. So it's coming from rectangle. So this is area from rectangle, get color, from shape, get side, from square. And this is a compilation error because get side is not available in shape. So if I do this, then I'm going to see that this one has a problem. Maybe just okay. Let's keep moving. Take note that we downcast shape S4 to rectangle, which is a superclass of square instead of square. So let's pay attention to this thing. Now, S4 is a shape, but inside of that shape I have a square. Now here, this S4, I'm converting the shape into a rectangle, and then I'm storing it into R2, which is a rectangle. Now, first of all, I'm putting a rectangle into a rectangle, so that's fine. But can I convert S4 to a rectangle? While S4 is a square.
Yes. So basically, I'll make upcasting. Let's go.
Which one? Which way can I go? Can I go up or can't I go down? Which one is the thing that is permissible? Now, what am I doing? Am I doing downcasting or upcasting? It's some kind of down upcasting, because the S4 is shape, but inside of it it's a square. Now, if I convert a square, can I put a square into a rectangle? Yes. No? Can't I put a square into?
Of course I can.
The rectangle is the superclass of the square. So if I do this, should I see a compilation error? No? Who says yes? Who says no? No, who says no? Just raise your hand just to have an idea. Who says yes? What about the others? Half yes, half no? Yes. Now S4, what is the other type of S4? It's a shape. But inside of it, it's a square. So it's a square inside of a shape. Now when you convert this into a rectangle, are you going to do the conversion of a shape into a rectangle or a square into a rectangle? That's the question. What do you get from this one? Which one is happening? There's no mistake, there's no error, which means it's the square that is going to be converted to a rectangle, and that's upcasting, but I'm doing a downcasting that is doing some kind of upcasting. So it's kind of a complicated downcasting. You didn't get it? Okay, let me try to do that with my board. Now, that's not a board, but it's just, imagine that this is S4. So S4 is a shape, right? But inside that shape I have a square. Now I have another variable which is R2, which is a rectangle. Now what I'm going to convert this to what's inside and put it inside of rectangle. I'm putting and convert it to a rectangle. But what we do the conversion, we look what's inside, and this is what I'm converting. I'm not looking at the base data type. I just look what's inside of this. This is a square, which means I'm converting from a square to a rectangle. So it's going to be here like this same thing, but as a rectangle. It's a because I'm downcasting, and then it's a downcasting included in upcasting. It's an upcasting if you look at what's inside of this, but if you look at what's the data type of S4, that's downcasting. But it's a special downcasting. Yes. So now that we have this, if I do this thing, it's a toString from where? A square or a rectangle? Square? Rectangle? Why? Why is it going to be a square?
Same as before, because I'm looking shape of the square inside it. Rectangle is square is inside the triangle.
So the same thing, because when we do something like this, like this here, we're just this object, we're going to put it into a superclass, one of its superclasses. So when we did something like this, it's the same thing. We're taking an object and putting it in a superclass. Well, not exactly, because I'm converting this to a rectangle. So it's going to be keeping the rectangle. Sorry? Not necessarily. No, not necessarily. Let's see. If this is part of it. And I want to show them all. You expect it to be a rectangle? Because when we convert, that's what I'm expecting too. It should be a rectangle. But it's not. It's a square. Why is it we expect it to be a rectangle? Because, well, we just converted to a rectangle. So it's expected, well, maybe we changed this. It's not a square anymore. This was becoming a rectangle. But then this was a square inside. So even when we convert it and put it into another one, it remembers that it was a square. So when you call something, it's going to try to see if it's available in square first. And if it's not, then it's going to go up. Because now we have a toString into square. That's why we are seeing this. If we did not have a toString from square, then the one that I'm going to be seeing is from rectangle. It's going to check what's inside, the real value, what's inside. Even if you do this kind of casting, this downcasting, it just doesn't forget what it was before. It's still there, but I just do this to be able to store it. Actually, what if I remove this thing? Is it okay? Nothing will happen? It's going to be a runtime error? Why? If I delete this, what should happen? Yes, Falah. You Googled it, so you might have found it. No? No, if I just remove this, and then we ask the question about square. Sorry? It's okay. It's a, what do you mean, runtime error or compilation or runtime? Compilation or runtime? Runtime? Compilation? It's going to be a compilation error. Why?
Because it's like we put shape inside the rectangle.
That's what you're trying to do. it just looks S4. What is S4? It's a shape. Can I put a shape into a rectangle? No, because a shape is a superclass of rectangle. I can put a subclass into a superclass, but I cannot put a superclass into a subclass. What if I put square? Now, before typing it, what if I just type here square? First of all, S4 can be converted to a square? Well, yes, because inside this is a square, so I can put this to be a square. But then, can I put a square into a rectangle?
Yes.
Yes, because it's the rectangle is the superclass of the square. So if I make it square here, that's okay. Exactly. It will. This one is going to display the square. Yes. But if I do it this way, it's more confusing. But it just not forget where it comes from. It's coming from a square, and this is just a square changing where it is stored at. So this is a square stored into a shape. Now this is a square stored into a rectangle. That's what it does.
If I do a circle between the two,
If you do a circle,
yeah,
like what?
rectangle equal circle.
If you just try to make it circle, that's a good question. There's no relationship between circle and rectangle. How you cannot do this kind of upcasting?
Inherits from the shape.
The only thing that you can put a class into another class if it's one of its subclasses. Okay, so that clears out this thing. What about this get area? From the square, get color, shape, get side, square, get length, rectangle, square. Do we have a get length in square?
We have
We don't have get length. We have set length, but we don't have get length. So this is coming from the rectangle. Yes. Yes. If you have a new method defined inside, yes, it will be coming from the yes. No. Alaikum salam. No. Why? Very good point. The get side here, is it available in rectangle? Yeah, I missed that. This get side is going to give you a compilation error because it's in the square but it's not in the rectangle. So you cannot do r2.getSide because it doesn't exist in the rectangle. You can only call the ones that exist in the class that you're calling it from. Now this, it's possible to put a subclass into a superclass, but when you call the method, you only call the method that are available in both or in the superclass. So for example, this one, if I copy the whole thing, this get side is going to be a problem because side is not available in rectangle. So this is coming from rectangle, shape, nothing, because a rectangle does not have get side, so this is a problem. And then this get length is from the rectangle. Yes. If you put what? Here? If you put shape, the get length doesn't work. This one, get side, is not going to work either. If it's a circle, square. If it's a square. If I make it square, then yes, but of course I cannot put a rectangle into a square. I just need to put a square as well from here. And then this time, that's not a problem. Yeah. Yes. Okay, now the last part is this thing. R2 is a rectangle, but inside of it there's a square. So here I'm just downcasting the rectangle to a square, which is okay in this case. Is it going to be a problem?
no, basically return the square to
It's just a square, then we put it back into a square. If I display this to string,
everything will work.
from a square, from a rectangle, from a shape, from a square, from a rectangle. So all these are not going to be a problem. And everything is okay. That was a good exercise that I hope that you benefited from. So you can get this downcasting, upcasting thing, and also when we call a method, which one is going to be called, and so on. Yes.
How does it take it color from shape?
Because look, if I'm inside of a square, if I'm inside here, I would like to see what is available. Everything from my superclasses is available. So the color is available, the field coming from the shape, as you can see, but also the length from the rectangle is also available. And also something from object. These are coming from object. So I inherit everything, and they're available in my class. So that's why I can call them.
It's taking a downcasting from 10.
Yes.
So it allows to take also from shape.
Because just square on its own, it inherits from all of this. It's not about downcasting. Just square inherits from rectangle, which inherits from shape, which inherits from object. So I have everything from all these classes. Okay.